Hello, hello. My name is Jones, and today we are going to look at the mechanism of antibiotic action. Antibiotics are used in medicine and agricultural science for bacterial infections and to also deter bacterial growth in food. There are several classes of antibiotics, and in this presentation, we are going to explain the bactericidal and the bacteriostatic activity of each antibiotic class that we are going to look at. So, within this lesson, we are going to look at penicillins, we are going to look at cephalosporins, we are going to look at aminoglycosides, we'll look at tetracyclines, we are going to look at macrolides, and also look at the fluoroquinolones. Okay, so the first antibiotic that we are discussing is penicillins. Penicillin is an antibiotic that was first discovered in 1928 by Alexander Fleming. Okay, and it was through some accidental experiment where he left a bacterial culture near a window, and then it got contaminated, and after some time it was found that the bacteria that were on the culture media had been killed or were killed by the fungal material. So because of this accidental incident that happened where Alexander Fleming discovered penicillin, it led to the discovery of the compound that was active in killing these bacteria that were on the culture. So this compound was later named penicillin by Fleming himself, and penicillin is considered as part of a class of antibiotics that are known as beta-lactams. These antibiotics are characterized by a beta-lactam ring in the molecule center. And the function of this drug is to interfere with the synthesis of bacterial cell wall. Beta-lactam may stop peptide chains from cross-linking during the formation of new peptidoglycan chain, which is a major compound of the bacterial cell. Thus, a bacterium cannot necessarily maintain its structure integrity when you have destroyed the cell wall. It becomes vulnerable to a lot of things entering it. Hence, it goes into lysis. So the structure of the beta-lactam ring or the beta-lactam is similar to the subunit that makes up the peptidoglycan. Okay, that is needed for the formation of the cell wall. So it therefore acts as a competitive inhibitor to transpeptidase, which is an enzyme that is needed for the cell wall there to form this peptidoglycan and then form up the cell wall. So the enzyme involved here is transpeptidase. So an enzyme involved in the cross-linking of peptides, also called penicillin binding protein, will interfere with this, and hence the cell or the bacterial cell will fail to form the bacterial wall, hence becoming vulnerable or going into lysis, or the cell destructs. Okay, so what we are simply saying is that penicillin belongs to antibiotics that are known as beta-lactams. Okay, and these beta-lactams destroy the cell wall of a bacteria, preventing it from effectively continuing to perform its function. Okay, so when that has happened, then it will cause the destruction of the cell. The next antibiotic that we are going to look at are cephalosporins. Okay, so cephalosporins also belong to antibiotics known as beta-lactam group. Okay, they are very similar to penicillins but contain a different structure, which provide increased resistance to inactivation by an enzyme which can be produced by certain bacteria called beta-lactamase. Okay, so if you, for instance, have some, let's say some bacteria that have developed some penicillin resistance, okay, this enzyme known as beta-lactamase will be produced, and penicillins will fail to perform their duty of destruction of the cell wall effectively. So you can resort to using cephalosporins. Okay, so they belong to the same group, but they are very similar with penicillin. But with these, they have an increased resistance to inactivation by an enzyme which can be produced by certain bacteria, which is called beta-lactamase. So this one is produced in resistance to penicillin. So cephalosporin antibiotics can therefore be used when penicillin is ineffective, okay, where the resistance has developed. So beta-lactams for cephalosporins have an ARA group or have ARA groups that modify the antibiotic to give a different spectrum of activity when it is destroying the cell wall. Cephalosporins have two ARA groups compared to one group that we see in penicillin. Hence, this will help to create more opportunity for chemical modification of the bacterial cell wall in its destruction when we are using antibiotics. Okay, so cephalosporins being a very good second choice of drug if you are treating penicillin-resistant bacteria. Okay, so the next group of antibiotics that we are going to look at are aminoglycosides. Okay, so aminoglycosides are bacteriostatic in nature. When I say bacteriostatic, I just mean they slow down the growth and the reproduction of bacteria without necessarily killing the bacteria. So these antibiotics inhibit the synthesis of proteins by binding to the 30S bacterial ribosome subunit. When the subunits bind together, they produce the proteins that are needed by the cell. Okay, so ribosomes in animal cells, we have 80S, okay, and then they're also made of subunit 40S and 60S. But when you talk of bacteria, we have 70S. So if we have 70S subunits and 30S subunits within the bacteria, we are going to be specific in modifying this subunit within the bacteria so that we can achieve the goal of bacteriostatic nature of these antibiotics. So aminoglycosides, what they will necessarily do is that they will prevent the effective proofreading of the proteins that are produced by the bacteria. They will cause incorrect amino acids. Amino acids, these are basic building blocks of proteins. So they are going to cause incorrect amino acids to be inserted into the peptide chain. Okay, hence this will create a misfolded or faulty proteins. Okay, so their function here, necessarily we are saying many of these structural proteins, okay, so if they are of defect because of the activity of aminoglycosides, it will cause the bacteria to fail to repair itself. As you know, we need proteins, even as human beings, to repair worn-out tissue. So even a bacteria will need proteins in order for it to repair worn-out tissue and sustain its life. So if there is no use of these proteins, the bacteria will go into lysis, or the bacteria will fail to reproduce. So it will not undergo growth because there are no proteins to help build up its growth. So aminoglycosides just prevent effective proofreading of proteins that are produced by the bacteria, hence causing an incorrect amino acid to be inserted within the peptide chain, creating a misfolded or faulty proteins. The best example necessarily that I can give, it's like you're building a house using concrete blocks, and then you have pseudo blocks that are made of ice. They look more like concrete blocks, but they are made of ice. What will happen is that it will weaken the structure, especially when the sun comes, because those pseudo blocks, pseudo meaning false blocks that are made of ice, are going to melt away and weaken the structure. So that's why we are saying if the proofreading of this protein is incorrect, the bacteria will fail to undergo cell growth and reproduce. Hence, we are saying aminoglycosides are bacteriostatic in that they slow down the growth and the reproduction of bacteria without necessarily killing the bacteria. Okay, so now we move on to another group of drugs. And remember, please, when we're talking about amino acids, we're saying they inhibit synthesis of proteins by binding to the third S bacterial ribosome subunit. So even this other drug that we're talking about, tetracycline, also inhibits synthesis, okay, by binding to the third S ribosome subunit. But it has a different method of action as compared to aminoglycosides. Instead of preventing proofreading of the peptide produced, they stop the binding of the transfer RNA to the ribosome, stopping the protein synthesis. So they interfere with the transfer RNA, okay, to the ribosome, so that the protein that the bacteria will need to reproduce or replace those worn out, that will not happen. So preventing the binding of transfer RNA to the bacterial ribosome effectively will prevent proteins being produced by the bacteria, leading to cell death. So that is what necessarily tetracycline do. So they bind to the third S subunit, and then when they bind to that unit, they will stop the binding of transfer RNA to the ribosome, hence stopping protein synthesis. So when you see people talking about the mode of action of tetracycline being protein synthesis inhibition, is because of this act. Okay, so now we can also look at another group of antibiotics known as macrolides. Okay, so macrolides have a similar function to aminoglycoside and tetracycline, okay, in that they inhibit the synthesis of proteins by binding to the bacterial ribosome, but they bind to the 50S subunit, okay, of the bacteria. So by doing this, they will stop the formation of peptide bonds between amino acids, preventing protein synthesis. So they bind to the third S subunit, effect similar to those of aminoglycoside and tetracycline, but they weaken the in-between chains between the peptide bonds, okay, these amino acids within the bacteria. So when they weaken those, then it will affect growth and then bring about bactericidal effect, okay, of the drug or the destruction of the drug. Okay, so then the last antibiotic that we can talk about is fluoroquinolones. Fluoroquinolones inhibit the activity of the DNA gyrase, which is a type of topoisomerase found in prokaryotes. Okay, so prokaryotes are just single-celled organisms that lacks a nucleus and other membrane-bound organelles. So fluoroquinolones are going to inhibit the activity of DNA gyrase, which is a type of topoisomerase found in prokaryotes, which will then prevent a harmful DNA modification, which is called supercoiling. Okay, so supercoiling occurs when DNA strands are wound together too tightly or not tightly enough. Okay, so this wounding or this that coiling, okay, so coiling within the DNA. So, and doing this supercoiling is essential for a bacteria ability to replicate. So DNA gyrase is a useful target for antibiotics in order to prevent this. So human cells do not contain DNA gyrase and have a different type of topoisomerase instead. So when we target that of the bacteria, then we are going to just kill the bacteria that is affecting human being and not necessarily tamper with the normal human being function. So there we have it. Today we have been looking at mechanism of antibiotic action. So we have just looked at some few antibiotics, that is penicillin, cephalosporins, aminoglycosides, tetracyclines, macrolide, and fluoroquinolones. there is a big range of antibiotics out there that we would have looked at, but for the sake of just this discussion, we have just looked at those. Remember, antibiotics are used in medicine and agriculture against bacterial infection and bacterial growth in food. And there are several classes of antibiotics that we can talk about, but we have just looked at their bactericidal and bacteriostatic activity within this lesson. Okay, so the first drug which we talked about was penicillin, which is said is an antibiotic that was discovered by Alexander Fleming, okay, in 1928, and it was through more of not purposeful but an accidental way when he was actually trying to do a culture but left the window open, and then this fungi penicillin, when it got contact with this culture, it destroyed some of these bacteria. So this fungi, Fleming's named it penicillin. Okay, so penicillin is now part of blood antibiotics that are used, and it belongs to beta-lactam. Okay, antibiotics. And then we also looked at another beta-lactam antibiotic that is good against penicillin-resistant penicillin-resistant bacteria that produce beta-lactamase. Okay, so the second antibiotic that we looked at was cephalosporins. Okay, so cephalosporins can help where penicillins fail to effectively kill the bacteria. These cephalosporins can come in and do their work. So that is why it's important that you leave professionals to prescribe antibiotics for you, because they know which choice they have to go to when the other one fails to work out. And we are always concerned to prevent increased bacterial resistance within the community by the indiscriminate use of these antibiotics in animals, okay, and other areas. Okay, so if you use them where you're not supposed to, it may lead to poisoning within the food chain, hence bring about bacterial resistance, because we would have brought them or eaten those same animals within the food chain, and then we start having these resistance. Okay, then we looked at aminoglycosides that bind to the third S bacterial ribosome subunit. Okay, so these subunits, okay, bind together and produce the proteins that the cell necessarily needs. But when you look at the human beings or animal cells, they have 80S, okay, and 40S and also 60AC liposomal subunits. But when you're talking about the bacteria, they have the 70S, okay, and can be built from the 30S subunits. So aminoglycoside necessarily prevents the effective proofreading, okay, of these proteins that are produced by this bacteria. Hence, when this has been modified, okay, then there will be problems or a fault in the proteins that are produced for the bacteria to grow and reproduce. Okay, then we looked at tetracyclines, which have also bind to the third S liposomal unit, but as they do this, they then interfere with the binding of transfer RNA to the ribosome, hence stopping protein synthesis. So in other literature, you can see that the mode of action of tetracycline may be quoted as bind to it to transfer RNA and this stop protein synthesis. Okay, then we also looked at macrolides. Macrolides bind to 50S subunit. And when you're talking about macrolides, we are saying they have similar actions with amino acids and tetracycline. Okay, but for macrolides, we are saying they bind to the 50 subunits and they stop the formation of peptide bonds between amino acids, preventing protein synthesis. They weaken the protein linkages within the bacteria, hence weakening the bacteria. Then when we talk about fluoroquinolones, okay, fluoroquinolones inhibit the activity of DNA guilase, okay, which is a type of toxomylase found in prokaryotes. Okay, then this will then prevent a harmful DNA modification, which is called supercoiling, okay, the bacteria that they can use in order to evade antibiotic activities. So this is necessarily what we intended to cover for this lesson, and the diagram just before me is trying to simplify this lesson on necessarily what happens in the mechanism of action of different antibiotics. So all this lesson has been simplified by the diagram in the background. Okay, so if you are a pharmacology student and you want to understand more, this lesson can be made available with notes using any of our links within our YouTube channel and other social medias that we use in order to conquer ignorance. So thank you and keep studying.